Welcome to Ask and Learn.
Okay, so for this problem, we're given an integral equation, y of x equals 4 plus integral from 0 to x of 2t times the square root of y of t dt. And at first glance, this might seem kind of intimidating, I guess, since you have x and t and integrals and all that. But actually, we can make this really simple using some fundamental theorem of calculus. So those fundamental rules that calculus always follows. So to start with, the first thing we do is we take the derivative of both sides. So this would become the derivative of y of x with respect to x. You can just write as dy dx equals, so the derivative of this would be 0 plus, and then you'd have the derivative with respect to x of this entire integral, 2t times the square root of y of t dt. And basically, this is the important part here because the first fundamental theorem of calculus, the first rule, basically says that the derivative of any integral, right, from a to b or a to x of a function is basically going to be equal to this function here. So what that's also telling us is that the derivative f prime of x, if I differentiate this side, if I integrate this side, then I'll get obviously capital F, which is one step higher, but the derivative would just be the normal thing. So from what we can tell from this is we can take this and we can apply that directly to here, and we can say that dy dx is going to be equal to 2x. So the derivative of this is just equal to the function, and the function here on the inside is 2t times square root of y of t. So we just plug x in there, and we'll get 2x times the square root of y of x dx. Right? We don't need the dx because the derivative in here will cancel out. So you'll have just 2t times the square root of y of x. 2x times the square root of y of x, my bad. So now, what this is telling us is y of x we can just rewrite as just y, because in this case that's all it is. So we'd have 2x times the square root of y, and now we can rewrite this, separating them, right? Applying the separation rule, so we take the dy dx and separate them. So we can divide this side by the square root of y and multiply this side by dx. And after you do that, you'll get dy over the square root of y equals 2x dx. And now finally, the last thing you have to do is simply integrate both sides. So you integrate this side with respect to dy, and you integrate this side with respect to dx. So another way you can rewrite this is square integral of y to the negative 1/2 dy equals, and an integral of 2x is really, really simple. So you can just go ahead and write x squared plus c. Don't forget that constant of integration. So yeah, so you have x squared plus c. You have x squared plus c there, and then on this side for the y to the negative 1/2, you just simply do the normal power rules, right? X to the negative 1/2 plus 1, and then on the bottom you're going to put negative 1/2 plus 1 as well. So that'll basically give you equals x squared plus c, and then the plus c, the the constant of integration you get from this integral will just basically just add on to here. So in reality you'll have like a c1 and a c2 here, but it's all just a constant. So c1 plus c2 is implied in this one single plus c over here. So you don't need to worry about both constants of integration. You can just combine them. And after all this, you'll end up with basically this will go to the top, 2 times y to the 1/2 equals x squared plus c. And y to the 1/2 is just a fancy way of saying square root of y. So you can go ahead and say that. And then now if we separate out y, then we can simply say y would be equal to x squared plus c over 2, and then this whole thing squared. Okay, but now we can actually substitute x equals 0 to our initial function here, which was this. So if we say x equals 0, then, because we need to find this plus c here, so we say x equals 0. So our, let me just rewrite real quick our original function here. It was 2t times the square root of y of t dt. And if we plug in y equals 0, then you'll get 4 plus integral from 0 to 0. That's really key. Of 2t times the square root of y of t dt. Now, if you remember the rule of integration, where if you're going from 0 to 0, then your integral will just basically be 0. So y of 0 will just be equal to 4. So now that we know y of 0 is equal to 4, we can use this. We just found out y here. So we can plug y of 0 is equal to 4, which is equal to 0 squared, which is 0. And then you have c over 2. C over 2 squared. So we take the square root of both sides of this little thing here. And you're left with 2 equals c over 2. And that means c is equal to 4. So now that you know that, you can finally go in and plug your c back into your final equation, which I'll change colors here for. Let's make it red. Y is equal to, what was it? X squared plus 4 over 2 squared. So that would be your final answer for evaluating this integral.